You can use the
Yes,
chat
sir.
box.
Visible.
Okay. So good afternoon, everyone. In the last session, we had discussed about the streaming data architecture, and these architecture included four building blocks. One of them is a master broker, data storage, and so on. So, in the last session, we had discussed about three blocks. Now we'll discuss about the streaming data storage. Basically, the problem with the data stream is a large amount of information which is being generated by the application. So you can find out that these applications are now common to everyone. For example, video streaming application like YouTube and streaming application like Spotify. So every user are using these applications and they are generating large amount of data. The storage of these data has a problem with the traditional storage technologies because they are not inexpensive. They are very cost consumptive technologies, as well as they are not fast enough to support the requirement of data stream architecture. So we have to find out a low cost storage technologies so that can support the streaming data architecture, as well as these technologies should be faster enough to support the requirement of the users as well as the service provider, so that they can employ the features like filtering the data stream. They can employ users can able to find out the specific content from the storage and so on. So most organizations today are storing their streaming event data. So that has become a common practice between the organization. So these organizations are whatever they are streaming from their platform, they are storing that information. So an organization can generate streaming data in the form of meetings, in the form of presentation, if they are conducting any event, so they can stream that information. As well as now you can say that most organizations are adopted to the work from home concept. So mostly what they are doing, they are collecting and acquiring those information from different sources, and these information are generated continuously from the users as well as the applications are as well as the different pages. So there are various streaming data storage options. Some of them are database, so we are already familiar with the database. Second one is a data warehouse, and third one is a message broker, and fourth one is a data lake. So let us discuss about each one, what their advantage and what are their advantages. For example, let us discuss about the database. So in a database, for example, PostgreSQL and so on, these are the SQL-based data analysis. So will create a query in SQL and you will fire the query, you will get your result. At disadvantage of that, they are hard to scale or manage. So when the amount of information stored in database is low, it's perfectly fine with the application because application can use the SQL based data analysis and perform the various data analysis on those storage data. But when the amount of information is scaled, means it is growing into large amount of information, then what will happen? These SQL-based query is not going to work there, and if you are trying to apply those concepts, then you are not going to get a better performance. So, what are the different solution of that? You can use the cloud-based storage, but you will find out that if you are using a database on a cloud, so it is a very expensive because cloud-based services are charging you as per your usage. So they are a pay per use model. So these model is very costly for creating a database for a large amount of information. So, same thing is also very much similar to the data warehouses. For example, Amazon Redshift. So they are also SQL based data analysis, and they are also not effective to the scaling and management. Second type of storage option is a master broker. For example, Kafka persistent storage. So these are massive stories are agile, so no need to structure data into tables. Easy to set up, no additional component. So they are much more familiar to the streaming data, and they are very using the agile. So you are not required to create any structure of data inside a table. And what are the disadvantages of this? Data retention is issue because it is a expensive compared to the other options available for the data storage. So it is quite being used if you are having a data data which is large enough, but if you are able to manage using the master broker and it is sustainable as per your cost factor, then you can use the master broker data storage. Next one is a data lakes, for example, Amazon S3. So it also have the same advantage which is of your message broker. But disadvantage is that it has a high latency, makes a real-time analysis difficult to perform with the SQL based analysis. So there are some disadvantages of data lake also, but it is a cost-effective solution. So worldwide, most of the organizations are adopting to the data lake technology for a low cost and efficient data storage solution. What is the future of streaming data? So you can find out that every organization which is generating a data in any form, they are trying to store the data because everyone is aware that whatever the information is being generated, that information can be used for any purpose in the future. Maybe if you are event planning company or you are creating an event as online streaming, so you can take the information of your participants, you can take the information from as a survey, and you can put all the information to find out some specific pattern inside that particular data so that you can take a better decision whenever you are planning an event or organizing any certain different kind of event. So you will find out that these things are going to be a future of streaming data. So in the near future, we can see that streaming data has two parts. One is a storage and one is a processing. So both will be decoupled from each other. So you will find out that if you have developed an application on data stream, and your application is very good to processing the streaming data, and you do not require to make a storage of that particular data stream. You can take any third-party sources. You can take the third-party software which is managing the storage of all the streaming data. You will store the information at that particular place. From table modeling to seamless modeling, modeling development. So automation of data plumbing. So these are the few points which is the future of streaming data. Now we'll discuss about the stream computing. So stream processing computational paradigm consists of assimilating data reading from collection of software or hardware sensor in stream form, analyzing the data and producing actionable result possible in stream format as well. So basically, we talk about here whatever the data stream is being generated from different sources. Now you have to be develop a software, you have to develop a process where you can perform various logical operation on those stream of data, and so that you can find out a required output. For example, whatever your expectation to analyzing some stream of data, and whatever the output usually that will be in a possible format. For example, if you are having a continuous stream of emails on your server and you have to find out the certain specific email that you are looking for within that email data stream, so you can apply the filtering on a email data stream. You will find out the certain kind of information. For example, you want to find out count the that how many users are accessing a particular web page on a website. You can apply the computing on that particular data stream of a web page, and based on that stream, you can identify that how many times a user has visited certain pages, what are the distinct pages is visited by the users, what are the users behavior, or what are the users time which is being spent on those particular website, so that a company can manage those websites in order to provide a better services to the user. In a stream processing system, application typically act as a continuous queries, ingesting data continuously, analyzing and correlating the data, and generalizing a stream of result. So when we are applying the stream processing, you can assume that whatever the data stream is generating, it is a continuous process of generating the data. So there will be no interruption while the data is being generated, and you are going to get a continuous stream. So there will not be any stoppage in the data stream. So application, if you are developing a stream processing or computing application, so they will typically act as a continuous query. So they will fire the request to the stream data stream if you want to filter out certain information. So your program, your application will continuously again search to the stream, and it will search on so that it can find out the required information. Why is it so? Because when we are dealing with the stream data stream, so you can find out that it can be a 10 to the infinite length. So it is a very large amount of information. It's not possible for your application that you can take all those information at a purpose at a one place, then you'll apply your logics, or you apply your searching, or apply your counting on that particular stream. So what will you do? You will take a sample from the stream, you will take a size of the stream, and you'll apply your logic or sampling or counting, and after that you will when the particular sample or size of the stream will be processed, they will go for the next upcoming size of sample of the stream. And when you process that particular size of the stream, then you will go on and go on. So what are we are doing here? We are taking a small portion of a stream, will process that particular portion. After that, I will move forward and process the another uh, part of the stream. Then after that, we'll process the another part of the stream. So here we are producing the analysis result as a stream of results. So when you are applying, so for example, if you are applying the filtering on the email application, so email messages, you will find out that it will continuously generating the information. If you want to identify a certain specific kind of email, so you are getting the result continuous, because your data stream is a continuous thing. So your output will also be a continuous. Application are represented as data flow graph composed of operators and interconnected by streams. So individual operators implement algorithm for data analysis, such as so these are certain example of application you can perform on the data stream. For example, you can apply the parsing, you can apply the filtering, you can apply the feature extracting, and you can apply the classification. So, guys, my question is here. Write down one question. The question is, what do you mean by feature extraction from a data stream? Write down the question. What do you mean by feature extraction in data stream? So, what I'm typing the question in chat box. What do you mean by feature extraction from data stream? So suppose if you are having a UT email data stream, so what can be your features here? How can you extract the features? Please take the 2 minutes of time, and please reply in the chat box, or you can unmute the mic and you can speak. Uh, Okay, so please, I'm expecting at least 4 to 5 response. What can be the features from a data stream? For example, if you are having a email data, so what can be a feature from a email data? Response, please. Or you can take any example. We have discussed numerous example in previous sessions. So you can take any example and find out what are the features you are trying to fetch from the data. What is the feature means that what are the attributes, or you can say what are the hidden patterns, or what are the similarity you are trying to identify from a data stream. Please provide response in the chat box, at least 4 to 5 response. Kavita, am I audible? Good. Spam filtering. Please elaborate, you see. What are the features that you will identify in spam as a spam? Pius, please respond in the chat box.
सर
I have got, yes, yes, please go ahead.
सर कुछ मेल में जैसे प्राइस मतलब लॉट ऑफ मनी या कुछ ऐसे वर्ड्स होंगे जिन वर्ड्स को हम आइडेंटिफाई करके ये स्पैम को फिल्टर कर सकते हैं कि ये मेल स्पैम है.
Very good, very good. We can also take the email address if they are anonymous in email addresses. We can also identify certain behavior. So basically, the common thing is that we'll analyze the word, that what are the different kinds of word or what are different set of words being used in the spam field. Very good, IUC. So these can be one features. You can also call it a filter because you are filtering some information from the email by using those certain kinds of words. But if you'll talk about to applying a machine learning approach while developing a model perform on the stream data stream, so we have to identify certain features, similarity between the data, so that we can apply those similarity and we can identify it as a feature. Very good, I see. Please, guys, one or two response, not 4 to 5, at least one or two response. You can also give an example of classification. What do you mean by classification from a data stream? One more response from Sakshi, recommendation based on customer choices. How can you correlate it with a data stream? Sakshi, please go ahead. Sakshi, my question is, how can you correlate your answer with the data stream? Okay. So please write this question as assignment also. Aditya, please note it down this question. And guys, please try to write the answer different from each other. Do not copy it because when you are dealing with any such kind of problem, feature extraction is a very important thing here. So we are proceeding. If you have any doubt, you can post in the chat box. So we can apply the parsing on the data stream. You can apply the filtering. For example, spam filter. You can apply the feature extraction. For example, you can apply the feature extraction on a video streaming. You can apply the classification. For example, your email, if mail is a spam or not, or you can identify a certain likelihood of an event also. So we'll discuss certain examples in next sessions where we'll apply some filtering technique on a real time examples, and we'll see how it works. So these algorithms are typically single pass because of the high data rates of external feeds. So you can find out that when you are using these algorithms, you have to be very much sure that whatever the information you are passing to your algorithm, that will be only one time, because when you will open the process the information, you do not have much time to process it again. So you have to be very much aware that whatever the stream of information is coming to your application, that should be processed fast. So, for example, market information from the stock exchanges. So, you can find out that if you develop an application for a stock prediction or a stock recommendation. So, in a market hour, you can find out that information is being generated continuously. So for every second, there will be a different information. So information will be changed for every second. So you have to, your application must have to be able to perform the analysis based on the updated information. Second example is environmental sensor reading from sites in a forest. So you can find out that as a nature is continuously changing throughout the day. So you can find out that these environmental sensors reading is changing. So they are not a unique kind of reading. They are a different reading at a different time. So when you are developing your application, you have to make sure that these are different outdated information can be processed in a fast way. These applications are usually constructed to identify new information by incrementally building model and assessing a new data deviates from model prediction. So why we perform this stream processing? Because we have to identify a certain pattern information from these applications. And why this pattern and prediction is important, because basically when we are developing any application, we are developing for it prediction, or we want to classify some information, we want to perform some regression on those information and so. So certainly we are trying to find out new information, or we are trying to classify the existing information into some predefined level classes. Please go through these example. For example, financial engineering. So you can construct a pricing model for option on security. That is a one example using the data stream analysis, while at the same time detecting mispriced quote from a live stock market. So if you are reading this example, you will find out that we are doing two things at a one time. So one application is developing a price model for option, and another thing at the same time when you are one application is running, you are detecting the mispriced cost from a live stock market. So you can create a multiple analysis on a single data. So this is also extended a form of the previous example. So please go through this one for 1 minute, then we'll move further. Okay, so next. Streams application. So it may consist of dozens to hundred of analytic operator, and it can be deployed on production system. It can be distributed over a large number of processing nodes. So when you are applying your Steam application, so it's not like that you will just deploy the whole application on your personal nodes or a single server. You will analyze the whole data stream. So it's not feasible for a data stream in a real time, because your data stream can be quite large in a size so that you have to use the distributed computing and apply your streaming computing on a different thing. For example, you can use the this Hadoop MapReduce system, which is a distributed clustering based system. So you can distribute the various data stream into different nodes, as well as you can distribute the task of your system to the different node. And after that, you will analyze the whole result and compile those results, and you will get a final outcome based on that. No. High performance computer system that analyze multiple data streams from many sources like you can find out that when you are working with a high performance computer system, so it can be used to analyze the data from a multiple sources. The word stream in a stream computing is used to mean pulling in a stream of data, processing data, stream it back out as a single flow. So what this sentence is mere means that when you are having a data stream from different sources, it doesn't mean that you will collect whole data stream and will combine those data stream as a single stream and pass to the user. No, you have to apply some processing, some manipulation on those data streams, some filtering on those data streams, so that these data stream which is filtered and processed will be passed to the user. For example, Google email application. So if you are using the Gmail, you will find out that whatever the data stream is coming to your application, it is by default filtered into different labels. For example, spam, trash, for example, inbox. If you have created a multiple different kinds of label in your inside your Gmail, then it will be organized based on that. So when you are developing an application, you must be sure that whatever the application is used by your streaming data, it will be able to process the data and stream on a live stream, and it will pass to the user. So it will use a software algorithms that analyzes data in real time, and it will use to increase the speed and accuracy when dealing with data handling. Now, this is example. So in 2007, IBM had a stream computing system, which is called System S. So it will run on 800 microprocessor, and it is a software-enabled application to split up the task, then reassemble the data into an answer. So this is an example of technical example of stream computing. ATI Technologies has a stream computing technologies, and it will enable the graphical processor to work in conjunction with high performance, low latency CPUs to solve complex computational problems. So you can see the technical part of the data stream is showing that when you are dealing with a large amount of data, actually you are working on high-end computing systems. So you have to deal with the GPUs, you have to be dealing with the CPUs, and you have to be very much sure that whatever the application you are developing, it is able to utilize the efficient resources in order to provide you a better computing capability. Okay, so ATI stream computing technology is derived from a class of application that runs on GPU instead of a CPU. So when you are developing such kind of application, they will highly dependent on the GPU apart from the CPU. So one question arises: why they want to depend on the GPU? Why not the fully depend on the CPU? Why the GPU is much more provide the much more performance compared to the CPU? Please response in the chat box. Why GPU is better compared to CPU? There are few more responses in the chat box. Good. Please write down those responses in detail in your assignment also. So my analysis why streaming computing technologies must be use the GPU instead of a CPU. Please respond in the chat box, or you can unmute yourself and speak. Okay, so there are few response in the chat box. IC has okay, GPU is faster than CPU. How can you say that? Justify. Okay, Sachi has given the justification. Okay, quite good. So please take this question as an assignment and write down why. The question can be why you will develop application based on the GPU instead of the full capability to the CPU. Okay, so I will leave this question for a discussion. Now, let us move further. So now our next topic is sampling data stream, sampling data in a stream. Let me go to the syllabus first so that you can get a idea what we are trying to cover here. Let me open the syllabus. Uh, Syllabus is visible to everyone. Is it visible? Syllabus? Okay. So if you go to the syllabus, you will find out that we have covered the streaming concept, streaming data model, architecture, stream computing. Now, these are the subtopics: sampling, filtering, counting, estimating moments, and counting oneness in a window, decaying window, and these are the application. One application RTAP, and there are case studies like a real-time sentiment analysis or stock market predictions. So we have covered the basic of a mining data stream, and now we'll go more technical in the data mining stream. For example, how to take sample of the data, how to filter some information from those samples. Okay, so do you have any doubt till now? Guys, do you have any doubt till now? Because now I will assume that you are very much familiar what is a data stream and what are the issues and challenges with the data stream and so on. Any doubt, any question? Should we proceed further? Okay, so I will assume that it is clear to everyone. Now switch the tab to the sampling data stream. So what is a sampling? So for example, if we have a data stream which is generated from a certain server. So it's not possible that you can process the whole amount of information at not possible. And if you want to apply some data analysis on that particular data stream, so it's not possible that you will first wait that all the data will be stored on your local server and you will apply the data analysis. Not possible, and as well as not accepted by anyone. Because when we are dealing with the data stream, what we are trying to do here, we are trying to make a flow. We are not going to stop the flow. So what we'll do, we'll take the flow, we'll process the flow, but we never stop the flow. So suppose you have a drainage water pipeline system within a city. So what can you do? You can take the water from a river, and now it is a data stream. Now you will apply some process on the particular the water, and you will pass to the consumer within the city. So now you are not stopping the flow. What you are actually doing, you are taking a water from a larger reservoir, and now you are processing those information and again creating a stream and pass to the various users. So, how can you, when you are trying to process water, you will not wait that whole river will come to your stream processing plant, then you will apply the processing. You can imagine that your water processing plant is so much large in the size, so much small in the size that it can't handle the whole river water. So what you have to do, you have to take some certain amount of water at a one time, and you apply the processing water. Now here can you can do the two things. One thing, you can take the fixed size of water to process at a time. So every time that particular fixed size of water will be inside your processing plant, you will process it. Otherwise, you can take a variable of flexible type of water is size. So based on the requirement, based on the user's requirement, you can increase or decrease the capacity of plant at a one time. So it depends on your application, what type of sampling it will take to perform on the data stream. So we will take this topic in a next class because if I will start with it one, so I need to cover some technical points here. So it's not basically feasible. So guys, if you have any question or answer, sorry, question or doubt, you can use the chat box to write the questions. And that's all for the today lecture. I'm stopping the recording and we'll discuss those questions we have given as an assignment here. Okay, thank you.